In this lesson, we are going to begin to graph the solutions of a quadratic function. Now, we began learning about quadratics when we did the AC method in Unit 6, but it is finally time for us to dive further into this topic. Unit 7 is all about quadratics. First thing, we need to make sure that we are all speaking the same language. So what do we call this form here? ax squared plus bx plus c. In this class, we call this general form. Now, some old textbooks and other people who may be helping you, or maybe even the internet, sometimes call this standard form, but we want to make sure that in this class we are calling it general form, and it is what we are always going to be referring to it as. So let's get started. What are the important aspects or characteristics of a parabola? The first thing we need to dive into is what does the graph of a quadratic function look like? First of all, we call the graph of a quadratic function a parabola, not a line. It's curved. It has this U shape either opening up or opening down. There are parabolas that open sideways, but you will not learn about those for a few more years, but just be aware that they do exist. As a reminder, every point on the graph of a quadratic function is a solution, meaning that when you substitute that point into the function, it makes the equation true. So now that we know about the name of this function and the graph itself, let's actually start to look at some characteristics. The first characteristic is the vertex, the point where the rate of change switches from increasing to decreasing or vice versa. Now, what does that actually mean? We tend to call vertex or vertices, for plural, maximum and minimum points. Maximum points occur when the graph or the parabola itself opens down, and a minimum point occurs when the graph opens up. So visually, what does that look like? This particular parabola opens down, so you can see that the vertex right here is the maximum or highest point. This parabola that's being drawn right here opens up, so the vertex itself is the minimum point. The vertex is an important point, and when we actually start to graph, we really are going to be focusing a lot on finding the vertex. Next, we have our intercepts, y-intercept and x-intercept, and this is the same characteristic from when we were graphing lines first semester. The y-intercept is where the parabola crosses the y-axis. It is the solution where the x value is 0. We always are going to write these in the form 0, a number, 0, 3, 0, -8. Whatever that value is, they're always going to be in this form. And there is only one y-intercept in a parabola. The x-intercept is where the parabola crosses the x-axis. It is a solution or ordered pair where the y value is 0. This time the number is going to come first, number, 0, 3, 0, 5, 0, -14, 0. Now, what's new about parabolas is that we can actually have more than one x-intercept. There can be 2, 1, or 0 x-intercepts or solutions, and we will look at these as we move throughout the unit, different examples of these. For us visual people, let's get this on a graph here. So the y-intercept is down here. Remember, the y-axis is the axis that goes up and down. So the y-intercept is where this graph crosses right there. And then the x-axis goes across like this. So quick question for you. How many x-intercepts does this parabola have? Hopefully you said 2, and they are located right here in yellow to match our colors. The last characteristic on this slide is the axis of symmetry. This is a new concept that only parabolas have. It's an imaginary line that cuts the parabola in half and is written as x equals the x value of the vertex, or simply x equals a number. Visually, that's located right here on a graph. Notice it goes right through the vertex, and it is a vertical line because Vux lines are vertical. 3 more characteristics here are zeros, x, or domain and range. Zeros are the x values of an x-intercept, and we always write them as x equals a number. Once you know the x-intercepts, it's really easy to find the zeros. And lastly, our domain and range, which again, we've talked about already this school year. Domain is the input values of a function. In other words, the domain values are the x values of a function. We read a domain from left to right, and it is written as -infinity to +infinity for all parabolas. Notice the parentheses. These details are really important in order for you to get full credit on a quiz or a test. And we always use parentheses with infinities because we never actually can reach infinity, so those values are not included. And then the last characteristic is the range, or the output values. The range values are the y values of a function. We read range from bottom to top. And if you have a minimum graph, our range is always written as y value comma infinity, specifically the y value of the vertex. Notice the value itself has a bracket because it is included, and the infinity always has that parenthesis. If you have a maximum, it's going to be reversed, this time negative infinity to y value, again with the parenthesis and the bracket. Notice I also added the note here, this is only for parabolas. Each function itself has its own domain and range. If you're following the rules of left to right for domain and bottom to top for range, you should be good to go when getting domain and range of any function. So now that we've talked about the functions, let's go ahead and do some practicing. So we have these two problems here. We'll do these together. The directions here say to label the vertex, y and x intercepts, and then list domain, range, and zeros. So the first thing we need to label is the vertex. Because this graph opens down, the vertex is going to be the maximum point or the highest point, which can be located right up at the top here. Next is the y-intercept, and that's coming in here in orange. Remember, the y-axis goes up and down, so this particular graph crosses the y-axis right at this orange point. And this graph has two x-intercepts, most parabolas do, and they are located here in yellow. Now that we've found the x-intercepts, we can go ahead and label our zeros, list our zeros, excuse me. Remember, zeros are the x values of the x-intercept, so I see an x-intercept at -1. And at +3, so we're going to write those as x equals -1 and 3. This symbol right here is an and symbol. It's how I write my and. Sometimes you'll see a comma there, or maybe even the word and, but again, this symbol right here is and. Domain for all parabolas is -infinity to +infinity. And range we read from bottom to top, but we're not quite ready to look at that yet. Let's actually read from bottom to top here. So when you go all the way to the bottom, the first thing you encounter are arrows, and those arrows are pointing down towards -infinity. And we're touching the graph, touching the graph, touching the graph until we hit the vertex. Because we're talking range, we want the y value of the vertex, in this case 5. So we actually are going to write the range as -infinity to 5. Again, the first thing we encountered was -infinity. The last thing we encountered was 5. Parentheses always on the -infinity, or +infinity if it was, and then a bracket next to the number. Now let's do one more together before you try one on your own. This time the graph opens up, so the vertex is going to be the minimum, which is located right here. Keeping our colors consistent, you're going to see this in red. Next is the y-intercept in orange. This one is located right at 0, 0. And the x-intercepts are coming in here in yellow. Again, we have two x-intercepts because the graph crosses the x-axis twice. Something very unique about this graph, notice at 0, 0, we have both an x and a y-intercept. 0, 0 is the only point where you can have an x and a y-intercept because you have 0 in both the x and the y positions. Now that we've labeled everything, let's list the domain, range, and zeros. First is the zeros. So if we go back to our graph, we have x equals 0 and x equals 8 for our x-intercept. So that's what we're going to write down for our zeros, x equals 0 and 8. All domains, -infinity to +infinity. And then the range we read from bottom to top. So this time we actually encounter the vertex first. That vertex, the y value is +3. And then it goes all the way up till we hit an arrow pointing up to the sky towards +infinity. So our range is -3 to infinity. Now there are two problems for you to try. So go ahead and pause the video, try these two problems, and when you're ready, hit play and check your work. So go ahead and pause the video now. Okay, let's see how you did. The graph on the left, here are the answers. We have a vertex down here. Again, this is a minimum point. Y-intercept up here and two x-intercepts here. The zeros are located at -3 and -1. Notice this time I used a comma instead of an and symbol. Either or, I'm indifferent. Make sure you use the x equals though. All domain is -infinity to +infinity. And then the range we read from bottom to top. So this time the first thing we hit is the vertex, -2, all the way up to these arrows pointing towards +infinity. Then the one on the right, here are answers here. Notice the vertex and the y-intercept are in the same place. That happens sometimes. Sometimes the x-intercept and the vertex are at the same place. It all depends on the graph. And then we have two x-intercepts located right here. The zeros are at -6 and +6. Don't forget your x equals. Domain, -infinity to +infinity. And range, -infinity to +3. Now, if you have any questions, make sure to reach out to one of your teachers to get some help. It is really important that you understand this before moving on. So feel free to look out for office hours on Zoom or send Mrs. Newman or me an email. So now that we've labeled some and listed some characteristics, we're actually going to look at the problems the way they were going to look on a quiz or a test. So notice it says find the directions, say find the characteristics of a parabola, fill in the table with the characteristics of the parabola. Now, this characteristic box is going to be the same on every single parabola that you make. It doesn't matter the order that you fill these values in, as long as you have them all filled in the end. Now, I'm going to go from top to bottom just for simplicity's sake, but you can fill in these characteristics in whatever way you want. So starting at the top, domain. Domain's always -infinity to +infinity. That should, at this point, hopefully be in your brain, ingrained in your brain. Range we read from bottom to top. So we're going to go from vertex all the way up to +infinity. Which value do we want from the vertex? Hopefully you're telling me the y value. This is -1. So the range is -1 to infinity. Now the y-intercept, remember the note said that there's always a y-intercept and it's always 0, a number. Oops. But how do we figure that out? I don't see any place that this graph crosses the y-axis. So I'm going to have to do a little bit of algebra. If I know an x value, I can plug it into the function to figure out the y value. So f of 0, and then wherever I see an x value, I'm going to replace it with 0. Typing this into my calculator, I figure out that f of 0 is 24, and that is the value that I'm going to go ahead and write in my y-intercept. Well, I cannot see it. Every single function has a y-intercept. X-intercepts, where does the graph cross the x-axis? At 4, 0 and 6, 0. Now that we've listed those, the zeros should be pretty easy to get. Remember, always x equals a number. In this case, x equals 4 and x equals 6. Next is the vertex. In this case, we have this low point here, our vertex. Remember, all ordered pairs are x, y. So that ordered pair in this case is 5, -1. Our axis of symmetry equation is always going to be x equals the x value of the vertex. The x value of this vertex is 5. So we have x equals 5 for our axis of symmetry equation. And then lastly, is the vertex a maximum or a minimum point? The vertex on this particular graph is the lowest point, so we're going to go ahead and circle minimum. Okay, on to the next problem here. This particular graph opens down, but we still can get the characteristics nonetheless. Domain, every parabola has a domain of -infinity to +infinity. Range, we're going to read from bottom to top. So I have arrows first, -infinity, up to the vertex, which is 4. Make sure you have the parenthesis next to the -infinity, and 4 next to a bracket next to the 4. My bad. Y-intercept, this particular graph, we can see the y-intercept, no math necessary. That y-intercept is located at 0, 3. X-intercepts, this graph crosses the x-axis twice at -3, 0, right here, and 1, 0 right here. The zeros are those x values. Make sure you have x equals, in this case, x equals -3 and 1. The vertex is located right here, x, y, don't forget, -1, 4. Axis of symmetry, x equals -1. You always take that x value from the vertex and drop it into the axis of symmetry equation. And then is this vertex a maximum or a minimum? This vertex is the high point, otherwise known as the maximum. Okay, one more example for you here. I challenge you. I know that this is maybe challenging, but please pause the video. Try to fill in the characteristic box the best that you can. When you're ready, hit play and check your work. So go ahead and pause the video now. Okay, let's see how you did. Here are the characteristics. Okay. If there are any characteristics that you are confused about, again, please reach out to Mrs. Newman or myself. It is really important that you understand these characteristics before we can move on and actually create the graphs ourselves. Now that you've gone through this video, go ahead, log into ClassKick and complete the worksheet on this same topic. If you have questions on ClassKick, you can raise your hand or ask others for help, or drop in for office hours and check Schoology for that. I hope you guys enjoyed this first e-learning video, and hopefully we see you soon. Thank you. Bye.